Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 24 Computer Networks dealing with Transmission Control Protocol, shortly known as TCP, which comes under Transport Layer. Please do like, share, subscribe, and comment. Come, let's go into the video. So, what is Transmission Control Protocol? It is said to be a reliable protocol, and it is also said as a connection oriented protocol. In the last video, we have seen that UDP is a connectionless protocol. So, now TCP is said to be a connection oriented protocol. So this TCP ensures that the data is reached to the destination with pakka accuracy. And TCP provides many error checking mechanism and also flow control mechanism. TCP, it provides full duplex communication. That is, it can send and receive data at the same time. So because of that, the accuracy and the efficiency of the system is being improved through this protocol. And this TCP provides end-to-end communication. It see that from the client to the server, the communication is done accurately. And it also provides flow control. So because of flow control, the quality of the services is obviously improved. And the TCP operates in a client server, that is point to point mode. You will have a client and a server, and between the client and the server, it is obvious to have many nodes. That is called as point to point mode. So at each and every point between the client and the server, the error and the flow control is being checked to maintain the quality of the services. So this is the header of the TCP. The size of the header is being fixed, and it is said that it is 8 bytes. So see here 0 to 7, 0 to 7, it goes on repeating because it is not a variable, it is fixed, so it is 8 bytes. It has source port, destination port, sequence number, acknowledgement number, data offset, reserved part, flags, window size, checksum. There is a field called urgent and an option. Now you will be seeing all these in detail. So you obviously know what is source port in all the protocols we are seeing. So here the source port it is 16 bits. It identifies the source port of the application process on the sending devices. The destination port is nothing but it is also 16-bit, and it identifies the destination port of the application process. Why sequence number? The sequence number here is 32 bits, and the sequence number of the data bytes of the segment, it is one which provides the sequence number for all the packets that is being transmitted from one end to the another end. Acknowledgement number, this is also 32 bits. So acknowledgement number it is in a form of flag. If when acknowledgement flag is supposed to be set, then this number contains the next sequence number of the data bytes that has to be transmitted and works like as a acknowledgement of the previous data that is been received. Right? Got understood? Next is data offset. What is data offset? It is 4 bits, and this field implies the size of the header, that is that will be 32 bit, and also the offset of the data in the current pocket that is running. So the whole segment of TCP will be covered in data offset. Next is reserved. Reserved is just a 3 bits. That is, it is reserved for the future use. If there is some default zeros or ones that has to be occupied, then this place is reserved for it. Next is flag. So whatever flag is set, it is of 1 bit. It might be overflow flag or whatever flag that is set during the transmission, then that flag is indicated here when the flag is set. And next is the window size. What is window size? This window size is nothing but the sliding window mechanism that we use. So here the window size, this is used for flow control between the two ends, client and the server, and it also indicates the amount of buffer, that is the amount of bytes the receiver has allocated for a particular segment. Be clear, this window size, it is used for flow control between the two ends of communication. It also ensures that indicates the amount of bytes the receiver, that is the receiver end, has allocated for a segment. That is how much data the receiver is expecting to fill the size. Got it? Next is checksum. Checksum, this field contains a checksum of the header, data and the pseudo header and performs checksum when as and when required to prevent the error. Next is urgent. Urgent is nothing but you will call it as urgent pointer. This points to the urgent data byte if this urgent flag is set to 1. When this urgent flag is set to 1, it is only a urgent field that is provided. Now you will be seeing how this urgent flag is set to 1. Now in this option, what is this option? It facilitates the additional options which are not covered by the regular header of the TCP. So this optional field is, it is a 32-bit words, and if this field contains data which is less than 32 bits, then it is padded with number of zeros or ones to form the complete 32-bit data. So now you will be seeing that how the urgent data is being set. Now these all I have already explained. Whatever it is there in the header, I have explained it. Now this is the control field. Now you will be seeing how urgent pointer is valid or not. So your TCP contains a control field. This is the control field URG, that is urgent pointer. ACK is nothing but acknowledgement. PSH, push, it is requesting for push. RST is nothing but reset of the connection. SYN, synchronization. FIN, termination of the connection. So what URG does is, it indicates the urgent pointer field which has a significant data and that should be processed. So whenever this URG is set to 1, the data under that field will be processed. And obviously you know what is ACK. It indicates that the acknowledgement field has a significance. That is, if ACK is cleared to 0, it indicates that the pocket does not contain any acknowledgement. If it is 1, then it is understood that the receiver end is sending the client side that the pockets have been received and the acknowledgement is positive. Next is PSH. PSH is nothing but request to push. So when it is set, it is a request to the receiving station to push the data. As soon as required, it pushes the data to the receiving application without any buffers. And RST. RST is nothing but the reset flag. So this reset flag has some features like it is used to reject a segment. If it doesn't need any segment, it will reset the connection. It can restart the connection and it can even refuse any incoming data or connection. Sync. So this is synchronization. This flag is used to set up a connection between the host. It will synchronize both the ends. And FIN. This flag is used to release a connection and no more the data will be exchanged. That is, it is a termination of the process. Got it? So this is the control field that is available in TCP header. So here you can see a initiator and a responder. Now synchronization is done, synchronization acknowledgement is done, and acknowledgement again it is back done. So how the communication takes place here. Now the establishment of initiator and responder must be done. So the client, that is the initiator, initiates the connection and sends the segment with some sequence number. That sequence number will be assigned for each and every pocket. Now this receiver, that is the responder, acknowledge back with its own sequence number and also with a message of acknowledgement. And now the client, after receiving that synchronization, that is the data and the acknowledgement, what it does is it is sending back an acknowledgement again to the server to respond the communication, and such this is how the communication in TCP takes place. So now if either of the server or the client can send the TCP segment with the termination connection flag set to 1. When the receiving end, that is the responder, ends the ends responds it back by acknowledgement FIN, then the direction of TCP communication will be closed, telling that the connection is done and it is released. So here during this initiator and responder synchronization acknowledgement, bandwidth management is also done. That is, the window sizes provided for each pocket, and it ensures that each of the size is completely filled when it reaches the responder. So bandwidth management is also done during this communication. And next is, there are some features or characteristics that is given by your TCP. One is error control and flow control. So this TCP uses port number to know what application process is running, or what application process has to run the next. So along with that, it uses some sequence number to synchronize itself along the different host. All the data segments are sent and received with sequence number, as I told. So now this TCP, when it uses sequence number and synchronize with each other, it is obviously having some error control and flow control that is synchronized between the sender and the receiver. Next is your multiplexing. So multiplexing, you obviously know what is multiplexing. It is a technique to combine two or more data streams in one session. That is, many data combined together is called as the multiplexing. Now, using TCP multiplexing, a client can communicate with any different application process in a single session. It is not that the client can communicate only to one server. It can communicate to n number of servers at the same time, like how full duplex communication takes place. Next is congestion control. So when large amount of data is also fed to the system which is not capable of handling it, congestion will occur. But in TCP, what happens, even if large number of data is sent, it is providing a control, congestion control, that is maintained using a timer, and such that it ensures that no congestion takes place in the network. So these are some features or characteristics that is produced by your TCP. So what is the advantages of TCP? It is connection oriented. It is reliable and also connection oriented protocol. It gives an error checking mechanism, and also after, if there is an error, it provides a recovery mechanism also. So obviously when there is an error checking mechanism, it also provides us a flow control mechanism. It also exhibit communication that is done end to end, not host to host, end to end. Finally, this protocol will exhibit full duplex communication, and both the receiver and the sender have the roles to send and receive data at any time, which improves the quality of the services. So obviously these are the advantages of TCP. Hope you would have understood about TCP in detail. Thank you. Stay tuned for more information.